All right, I am going to show you how to finish your lab. But before we get to this down here, here's how you finish it. Those are the instructions. We've got to know a little bit more about velocity time graphs. So here's what we already know. Let's review a little bit. If we have a delta x time graph and it's got some slope, or in this case a changing slope. The slope of this graph, slope equals velocity. Alright, now we're just beginning to realize as well that if we have a velocity time graph, and let's say it looks like this, the slope is equal to acceleration. Alright, and what we're doing is change in velocity over change in time, okay, which is the rise over the run. In calculus, they call this dv dt, and they have a fancy word called derivative. Alright, that's what we're doing here. Slope of this graph, the derivative is the acceleration. Okay, so we know about slopes. Now we're going to talk about areas. So what about areas under graphs? Alright, to connect this to calculus for some of you, you're not actually going to have to do the calculus, but there's a fancy name and symbol. Okay, the symbol is like that. It's called an integral. Alright, and it just means we're taking the area under a curve or under some graph. Alright, so we have this line here, and we hole punch through it here, so that's 4 meters per second. So something is going from 2 up to 4 meters per second. And that's happening in 5 seconds. So we could get the slope and all that and call it and figure out what the acceleration is. But for this part, let's take a look at area. There are only 3 questions that you can be asked about graphs. Analyze the slope is one. Analyze the area is another, and read an axis. That's all you can do with a graph. Okay, so here we're going to look at the area. So I'm not going to look at the entire area to start. I'm just going to look at this little square right here. And if I have a rectangle, the area is equal to length times width. Now the process that I'm doing right here, you should be able to do for any graph in the future. So let's call this the length, and let's call this the width. Okay, and the length, let's take a look at the units. Okay, the length is measured in units of seconds. So if I take this area, I've got seconds, alright, for that. And then the width, alright, that would be if I hold these lines over here, and the width of my rectangle would be measured in units of meters per second. So meters over seconds. Alright, and now you can see that the units cancel, or the seconds cancel, and we get meters. So for this, if I shade this in, if I were to actually calculate it, that would give me an answer in meters. Okay? Now that's not really very helpful to take just this little chunk, but if I can get the area of this entire thing here, that's useful information. This whole thing would be delta x, okay, which is meters traveled, for this 5-second interval as the person was accelerating or whatever was accelerating right here. Okay, so that's only for a VT graph. The area is going to give us meters. Alright, that's what you need to know to complete your lab. So down here you have another little slip of paper that looks like this. Let me grab it. Okay, and so you have a distance from your odometer that you recorded in number 4. If you didn't do that, you're going to have to go get your data again, because this lab's pointless without this step. Okay, and then you have all this data. Alright, I already showed you how to convert from miles per hour to meters per second. And so you've got some data lists, and you've graphed your data. So we made our graph, a VT graph, connect the points with the straight edge. This time we are going to actually connect the dots. Alright, which we don't do very often, but we've got these different points. Here's a sample graph. Alright, so what I'm going to have you do is find the area under each segment that you drew and find a way to neatly record those. So for the first 5-second interval, what I want to do is I want to calculate this area. So let's say I was going the same speed. This is a rectangle. That's super easy to calculate. Okay, so this side of my rectangle is equal to 3 meters per second. This side is equal to 5 seconds. So I just do 3 times 5. So if I call this segment 1, the area is equal to 3 times 5, which is equal to 15 meters. Okay, now my second segment is still 5 from here to here. Alright, but what height do I use? Because now I've got a sloped line. So here's what we're going to have to do. We are going to have to use the average for this segment. So between 3 and 6 here, that's going to be my average. So I got 4.5. And you don't have to mark your graph up this much. I'm just doing this to show you. And if you use the average, what you are doing for this interval, I'm going to draw a line across here. And maybe I'll extend this a little bit so it looks a little better. This right here, this blank space, should be equal to this right here. Okay, so what you're doing is taking this triangle, you're taking this triangle and you're putting it right there and you're making this thing a rectangle. Alright, to calculate the area under the curve. And so if I have this speed and this speed, I started here at 3 meters per second, I went up to 6 meters per second, my average speed was 4.5. So for segment 2 here, my area is going to be my average speed, which is 4.5 times 5 seconds. And if I do that on the calculator, I get 22.5 meters. So for all of your portions of your graph where you have a slope right here, for those 5-second intervals, you are going to do what I just did. You're going to use the average velocity, which basically makes this shape a rectangle. Okay, so you're going to do that for all of your portions of your graph. You might have a portion on your graph where you have a 30-second interval where you went the same speed. So your graph would, here's your time. Let me draw it on here. So if you have your big graph right here, over here you might have a 30-second interval where you went a speed of 15 meters per second. Okay? Instead of dividing that up into 5-second intervals and chopping this up, what you can just do is say, I'm going to make this one big rectangle, and you would just use the 30 times the 15. That'll shorten the amount of work that you have to do. Okay? So that's how you get the areas. And then number 4, you are going to add up the areas to get one final area for the entire graph. Alright, so a total area. That means I'm going to add up all of these numbers and I'm going to get some amount of meters. Okay, now it says down here do a percent difference. What you are doing is a percent difference between your total area. Okay, so total area we'll consider that to be our observed. And the odometer, that's going to be our accepted. Okay, because it's probably more accurate than what we did, we'll call that our accepted. So you're going to do a percent error between those two, and we will see how close our odometer was to calculating the area under the graph. And they should be pretty close. Hopefully that'll help you out to finish your lab. And the one other thing I can say here is that when you do your percent difference, your odometer is in miles. So if I want to convert that to meters, if you know how to do that, you can stop watching. If you want me to show you how to do this, keep watching. Let's say your odometer tells you that you went 1.2 miles. Okay? Question mark meters equals. Okay, how many meters are equal to 1.2 miles? So I can convert this by putting miles at the bottom and meters at the top. Okay, and now I need to know the conversion factor. You could look it up right here on the internet, but I'll just tell you this time. In 1 mile, there are 1,600 meters. 1,600. So if you run track, a mile is the 1,600, right? Now if we're going to be a little bit more accurate about it, 1,609 is more accurate. Okay, miles cancels. All I do is multiply and get my answer. Okay, and my answer will be some amount of meters. Alright, that's the end of the video. That lab's due tomorrow in class. And hopefully you can see how your odometer matches up with your areas, and it's pretty interesting to see how close we can get. Alright, thanks for watching and good luck.